Alright, so we now proceed with our next example. Now, so this is activity 4, and let's proceed with our next example. So here's problem number 3. A closed horizontal cylindrical tank, 1.5-meter diameter and 4 meters long, is completely filled with gasoline. Specific gravity equals to 0.82 and accelerated horizontally at 3 meters per second squared. Find the total force acting at the rear wall and at the front wall of the tank. Find also the accelerating force on the fluid mass. Alright, let's analyze. So we have this problem, and in this problem, so we have a closed horizontal cylindrical tank. So this is a cylindrical tank, no? And it is full of gasoline, no? 100% gasoline, okay? So this is a cylindrical tank, so meaning this will be the three-dimensional view, no? Okay, so this is our tank, and it is in a form of cylinder. So in here it has a 1.5 diameter, 1.5 meter diameter, no? Okay, so the diameter is 1.5 meter, and the length is 4 meters. So the length of the tank is 4 meters. The specific gravity of the gasoline inside is 0.82. So if we analyze that, uh, take a look that this uh, tank is accelerated at a rate of 3 meters per second squared. Okay, so the speed of the tank, increases as time passes by, no, at the rate of 3 meter per second squared. So in other words, for every second, there is an increase of 3 meters per second in its speed, no? So it is accelerating in this direction. And take note that since the tank is 100% filled with gasoline, so tendency is that as it moves to the right, you know, the the force on the left side intensifies. The force in the left side intensifies in comparison with the force at the front. No? If it is not accelerating, the two are equal. No? The two are equal. The rear force and the front force. No? However, since it is accelerating and due to the reverse effective force, the rear, the back part, the rear part, no, experience the greatest amount of force, no, because it is accelerating in this direction, because the reverse effective force is directed on the left side, no, the reverse effective force. Take note that the reverse effective force direction and the acceleration direction are always in opposite, no. Therefore, since this is closed, and there will be no spilled liquid, no spilled gasoline. Therefore, there will only be an increase in pressure. And since there will be an increase in pressure, okay, we have here the pressure diagram now. Now, we have the pressure diagram for the gasoline. Okay, so this is the pressure diagram. So there is an additional pressure. Okay, this height represents a pressure increase. no? In this part, there's no pressure increase because the height is zero, no? Okay, the height is zero here. So in that case, if the height is zero there, whatever acceleration there is, the front force will no longer increase, no? So if it is zero, it's still the same, no? So if it accelerates, it's still the same. Unlike in the rear end, no, it varies in intensity, no, depending on the acceleration, no. The greater the acceleration, the greater will be the height, no. The greater will be this height. So meaning there's an additional pressure, and if there's an additional pressure, there will be an additional hydrostatic force being exerted on the rear side of the tank. Okay, let's now continue. So this part has an acceleration of 0, and we have the rear end of the tank and the front end of the tank. So we have the rear force and the front force. And this is 1.5 meter. Okay, this is the diameter of the tank. And we have here y. This is the additional height, no? Additional height that has something to do with pressure increase, no? So this is the angle theta, no, for our triangle, no? So this is the pressure diagram, which is triangular, no? And we have the rear force, as I have told you before, that it is equals to the specific weight, okay, multiplied by HC, multiplied by the area, no? So this was taught to you before, okay? So we imagine that the tank is open, okay? We imagine that the tank is open, and this will now be our height, no? So this will now be our height, okay? This is HC. So later, papakita ko yung HC, no? So in that case, so we have specific weight of gasoline. So that is specific gravity of gasoline multiplied by the unit weight of water at 4 degrees Celsius. And then I think HC rear. Okay. So HC rear is y plus 1.5 over 2. Okay. So ito yung ating y plus dahil ito yung ating tank, 1.5 meter diameter. Yung kanyang sa centroid ay 0.75, 0.75, right? 0.75, 0.75. Okay? So kung ganon, 0.75, 0.75. So we have y now plus 0.75 meter is equals to 8c. 8c rear. No? 8c rear. Okay? So ganon siya. So and next, as you notice, we have pi over 4, the area, the rear area. No? Itong part na to. Okay? Original pa rin, 1.5 meter diameter. Imaginary lang yun nandito, yung height na yan. Hindi yan kasama sa diameter, no? So ito yung actual diameter yung ating ko-consider, 'di ba? Ang area ng circle ay pi over 4d squared, pi over 4 diameter squared, no? Okay. And then tangent theta, as you notice, this is our triangle. So opposite over adjacent, no? So y over 4. This is 4 meters, so 4 meters, no? So tangent theta is y over 4. And we have now a over g, tangent theta. This is the formula I have derived before. That tangent theta, this angle is equals to a over g. No? A over g. So, in this case, parang ni-imagine natin na spill. Imaginary. Kumbaga, iting imaginary liquid na na-spill. Parang ganon. No? Although in actual, hindi naman talaga na-spill. No? So, still, no? Yan pa rin ang formula, A over G. No? So, we have, alright, so we are to solve for Y. So, that is 4 multiplied by A. That is 3 meters per second squared over G, 9.81 meter per second squared. Okay, cancel yung meter per second squared unit nila. And we will arrive with the unit of 1 of meter, which is Y equals to 1.223 meter. No? So, 4 ay nakameter. No? So, yun. Therefore, we can find the real force, which is the specific gravity of glycerin, 0.82, the specific weight of water, 9.81 kilonewton per cubic meter. So, this is kilonewton per cubic meter. Then, Y is 1.223. Then, ano magiging final unit natin? Kilonewton, no? So, ito ay kilonewton per cubic meter. Ito ay meter. Unit niyan. Ito ay square meter. So, cancel yung cubic meter. Matitira is kilonewton, no? Okay, so at 28.05 kilonewton. So, that is our real force, no? Next, the front force. Let's solve for the front force. For the front force, okay, same formula. Okay, so we have specific gravity of glycerin, of gasoline, 0.82, HC front, multiplied by the specific weight of water at 4 degrees Celsius. No? Yun yung specific weight of glycerin. HC front, kalahati lang na 1.5, no? So, yun yung ating para sa centroid, 0.75, no? Kalahati ng 1.5. And then, area, front, ito, circle yung front niya. So, pi over 4d squared, no? Pi over 4, 1.5 squared. Okay? So, we will arrive with 10.66 kilonewtons. So, that is our front force, no? The force at the front wall of the tank, no? Force at the front wall of the tank. Uh, Take note that this is the direction kasi inahanap, find also the accelerating force on the fluid mass. So this is the direction of the force, no? The force that is produced due to the acceleration of this system, which is the tank, no? Recall Newton's second law of motion, okay? The law of acceleration, wherein F equals to ma, no? Summation F equals to ma, no? So in this case, summation F represents F, and the product of the mass of the tank filled with liquid, no? In this case, the tank's weight was not indicated, or the tank's mass. So we disregard the tank's mass. Instead, we only consider the mass of the liquid inside the tank, no? So F equals to ma. So the mass of the liquid multiplied by the acceleration, that will be the corresponding force, no? That is exerted, no? So in that case, okay, the mass is the product of density and volume. 'di ba? So, kung meron kang specific weight, weight over volume, meron kang density, mass over volume, no? So, sabihin niyan, specific weight times volume, yun yung weight. Density times volume, yun yung mass, no? So, kaya density volume times A. Density of of gasoline, no? So, density of gasoline times the volume of gasoline times the acceleration. So, the density of gasoline, specific gravity of gasoline times density of water at 4 degrees Celsius multiplied by BL, the volume of the tank. The volume of the tank, area of the base, multiplied by the length, 4 meters, no? So that is the volume of the cylinder, no? So then multiplied by the acceleration. So we have specific gravity of gasoline, 0.82, density of water at 4 degrees Celsius, that is 1,000 kilograms per cubic meter, and the base, the area of the base is a circle. So area of a circle, pi over 4d squared. Length is 4 meters. Okay. Acceleration is 3 meter per second squared. So cancel. So matitira ay kilogram meter per second squared. What is kilogram meter per second squared? That is Newton, no? 1 kilogram meter per second squared, that is 1 Newton. And we have 17.39 times 10 raised to 3 newtons, no? So we have an answer of 17.39 kilonewtons. So that is our force at the front wall, no, of the tank. So as you notice, the force at the front is not the same as the force at the back part, no, at the rear part, no. So, and since we are to solve for F, how do we find for F? No, this is the accelerating force on the fluid mass. So, note that F equals to F front minus F rear. So, yun na yung nasolve na natin sa F, no, using the concept of Newton's second law of motion, mass times acceleration, kaya nakuha natin yung F, no? But there is an alternative solution. I have shown this before, that the force, no, can be obtained, no, the accelerating force can be obtained by subtracting two opposite forces. So ito yung dalawang opposite forces, rear force and front force. So we get the absolute value, no, front minus rear, and we will obtain an answer of negative 17.39 kilonewtons. So therefore, the magnitude of that is 17.39 kilonewtons. So that is, the absolute value is 17.39. That will give us an answer of the accelerating force equals to 17.39 kilonewtons. Huh? So that's it. So we now proceed with problem number 4. A vessel containing oil is accelerated on a plane inclined 15 degrees with the horizontal at 1.2 meter per second squared. Determine the inclination of the oil surface when the motion is upward, letter A yon, and letter B downward. Alright, given we have this vessel containing oil. It's accelerated on a plane inclined at 15 degrees, no? So, okay, with the horizontal at 1.2 meter per second squared. Okay? Determine the inclination of the oil surface when the motion is upward. So, when the motion is upward, ito yung inclination na tinutukoy. Ayan. Kasi, itong part na to, let's say line 1, ay parallel dito, line 2. No? Therefore, naka-incline yung ating liquid, which is oil, at an angle theta. Okay? So, determine the inclination of the oil surface when the motion is upward. So, that is when the motion is upward. Solution, recall that tangent theta, this was derived before, equal to AH over G plus AB, where AH is the horizontal component of the hydrostatic force and AB is the vertical component. No? Okay, so in this case, this is for upward motion only. This is applicable for upward motion. No? Plus yan, G plus. Pag downward, G minus yan. No? Okay, so I have told you that AH, no? So, ito acceleration natin. At ano yung angle dito ng acceleration? Katulad nun, yung beta, no? Beta yan. Okay? So, beta din yan. So, kung beta to, ito yung x component or horizontal component. Ito yung y component o yung vertical component. Where AH is equals to dahil malapit sa angle beta, cosine. Okay? Malayo sa angle beta, sine. No? So, A sine. Okay? So, ganyan yung ating outcome ngayon. Tangent theta equals to A cosine beta over G plus A sine beta. So, we have to find theta, that is arctangent. A is 1.2 meter per second squared. Beta is 15 degrees. G is 9.81 meter per second squared. 1.2 meter per second squared sine 15 degrees. So, anong magiging, makakancel yung unit, di ba? Meter per second squared over meter per second squared. Therefore, pwede na natin kunin yung arctangent. Will give us an answer of 6.534 degrees. Now, letter B. Downward naman yung kanyang direction. So, mapapansin nyo, pag pataas siya, yung reverse effective force, ito yung direction. Ito yung direction ng acceleration. Therefore, pa-left yung ating reverse effective force. At ang tendency ng liquid, mas maraming liquid yung mapupunta sa left. Pero, dito naman sa case na to, ito yung direction ng ating acceleration. Okay? So, dito yung direction ng ating acceleration. Okay? So, kung yan ang direction ng ating acceleration, ang reverse effective force direction will be the opposite. That's why, bumaba yung level. No? Bumaba yung level ng liquid dito, napunta sa kabila yung iba. No? Okay, habang pababa siya na nag-accelerate. No? So, with that, 15 degrees pa rin yung ating naka-incline yung plane. No? So, ating acceleration direction, 1.2 meter per second squared, directed downward, no? Directed on the left, no? So, take note that ito ngayon yung inclination, ito yung line 1, line 2. Yan ang reference natin. At naka-incline ngayon siya ng theta ulit, no? Naka-incline siya ngayon ng theta. Okay? At yung inclination na yan, ano kaya yung value niya? So, pareho lang ba na 6.5? Mataas ba sa 6.534 or mababa sa 6.534? Let's investigate. No? So, formula, no? Tangent theta, pag downward ang motion, okay? Yan ang formula. So, minus, ito yung gitnang sign, minus, no? Gitnang operation ay minus. So, A cosine beta over G minus A sine beta. So, arctangent, 1.2 cosine 15 degrees, 9.81 minus 1.2 sine 15 degrees, 6.957 degrees. It's higher, no? Compared dito sa 6.534 degrees. Pero, 7 degrees yan pag ni-round off ko. 7 degrees din to pag ni-round off ko. So, almost the same, no? Hindi lang sila exactly equal. Almost the same, no? Okay, so let's now proceed with our next topic, vertical translation of liquid masses, moving vessels. This time naman, naka yung nag-accelerate upward or downward, no? Vertically, no? Vertical acceleration, not upward or downward, no? So we have this tank, no? Itong tank na to, downward path acceleration. So sabihin, downward ang path ng ating tank at papunta siya at yung direction ng acceleration ay kapareho, no? Nung direction nung path. So in this case, ito yung ating tank. It's three-dimensional, no? Okay, so three-dimensional siya. At ito yung ating kuha tayo ng vertical strip. Yung vertical strip na yan, okay, consider natin. So meron dyan pressure, no? Meron dyan pressure. So, and then, sabihin natin yung sa at most part, sabihin natin ito ay open. Open. Pag open yan, pressure dito ay zero, no? Pressure sa surface ay zero, no? And in that case, ito yung ating pressure head, H, no? At meron tong specific weight, yung liquid na yan, no? Meron yung specific weight. At ito yung direction ng ating direction of travel of the tank, no? Pababa. Let's say bigla mo na lang binitawan yung tank, no? O nung bigla binitawan, nag-accelerate downward, no? So in that case, downward path acceleration, consider natin yung direction ng motion ay kapareho ng direction ng acceleration. This is case 1, no? Direction of the motion is the same as the direction of the acceleration. Consider natin yung vertical strip. At yung vertical strip na yan, represented by a particle. Sabihin natin, it is represented by a particle. We treat it as a particle, no? And we consider all the forces acting on it. First, we have the weight of it, no? The weight of this strip. Meron niyang bigat, yung strip na yan. At also, meron normal force, no? Meron siyang bigat, sa part na to, may pressure. At yung pressure na yon, nagdudulot ng force. Kapag may pressure, may force, no? At yung force na yon is normal. Normal to the surface, no? So normal. So pag normal, perpendicular, di ba? Kaya nga normal force, perpendicular sa surface, no? So merong normal force. So kasi may liquid dito sa ilalim at nag-exert yun ng force, which is normal force dito sa part na to, no? Pag kinonsider natin yung strip na yan, no? Okay? So, what else? The reverse effective force. Sabi ko nga, kung ito yung acceleration, the reverse effective force will be in opposite direction. So, it will be upward, no? Okay. So, with that, we can now sum up forces vertical equals 0. So, nandun na lahat ng forces na kailangan natin. We can now sum up forces vertical equals to 0. So, the reverse effective force plus the normal force minus the weight equals to 0. So, the reverse effective force is simply equal to the mass times acceleration plus the normal force. Yung normal force dito, no, ay pressure times area. Yung area dito sa part na to, no? Yung area sa ilalim, no? Pressure times the area, no? And then minus the weight of this vertical strip, mg. So ito yung strip natin at yung strip na yan ay yan talaga yung actual niya, no? Ito. So, yung strip na yan, meron yung third dimension. No? Okay? So, kasi ito yung ginaya niya to. Meron third dimension yung strip na yan. No? So, kaya nga siya merong bigat. So, ito ngayon yung area na tinutukoy dito. Actually, yung area sa ilalim, kapareho ng area na nasa ilalim, sa taas, no? So, dito, yung part na sa ilalim. Yung part na sa ilalim, okay, katulad din nung nasa taas, no? Yung area sa ilalim, katulad nung area na nasa taas. Okay? So, therefore, para hindi mahirap i-illustrate, ito na lang kinonsider ko yung taas. Kapareho din naman sa ilalim, no? Okay, next. O yan. So, PA equals to, inayos natin, transpose. So, mg minus ma, no? Magiging mg minus ma siya nun. Tapos, mg minus a siya nun, no? Okay, ganyan siya. Next, so PA equals to rho V, mass. Yung mass ng yung mass nito, itong strip na yan, yung mass niyan ay density volume times G minus A. No? So, meron niyang density. So, yan, density yan. No? Then, meron niyang height. Ito. Na kung saan ang volume ay AH. No? Area of the base times the height. No? Area of the base, so BL. Ito yung BL. Yung A ay yung B, yung H ay yung L, BL. No? Okay, area of the base times the height. Okay? So, ito yan ang simplified form. PA equals to rho A H G minus A. So, volume is AH, no? So, cancel yung A, no? Cancel yung A. So, rho H na lang, G minus A. At yung rho ay gamma over G. Recall yung formula na na-derive ko before, that specific weight is density times acceleration due to gravity. Na-derive ko na yan before, no? No? So, yung unang part pa, no midterm pa yan, no midterm. That specific weight equals to density times acceleration due to gravity. Therefore, ang density ay gamma over g. Specific weight over acceleration due to gravity. Yun yung density. Times h, g minus a. No? So, therefore, the pressure equals to, so, pwede nating iyan to, yung denominator i-separate, no? So, pwede nating isulat na P equals to specific weight times height 1 over G tapos G minus A. So, sineparate natin yung over G. Ginawa natin 1 over G. So, 1 over G times G, that is 1. 1 over G times A, that is A over G. Kaya naging ganyan yung resulta. No? So, yan na yung formula natin gagamitin ngayon pag nag-solve ng problem. So, ibig sabihin yan, class, pagka nag-accelerate yung ating object, yung tank na to, nag-accelerate, no? Yung pressure na apektuhan. No? Kasi kapag at rest yan, at rest, meaning hindi nag-accelerate, so zero yan, sabihin ang pressure natin ay simply specific weight times height. Yun yung dating naturo ko, di ba? Yun, hindi nag-accelerate. Kaya nag-accelerate at downward siya, no? Na kung saan ang acceleration ay kapareho ng direction ng motion. Kaya naging minus A over G. No? So, yun ang ating formula. Okay, next. Ito naman yung case 2, downward path deceleration. Okay? O kapag merong, ang pinagkaiba lang pag sinabing acceleration, there is an increase in speed, no? In speed or velocity. Pag sinabi nating deceleration, no? It's the opposite. There is a decrease in speed or velocity. Okay? So, yun ang ating deceleration. So, in this case, pareho pa rin. Yan pa rin naman yung tank natin. No? Ayan. This time, it's the opposite. No? The direction is opposite. So, downward path na nababawasan yung bilis habang pailalim. Okay? So, pag nababawasan yung bilis habang pailalim, ang direction ng acceleration is upward. Is the opposite in the direction of the path. No? So, yun ang direction ng ating acceleration. No? So, in that case, no? So, ito yung ating ko-consider pa rin. Ito yung weight. And then, ito yung normal force para dito. This time, dahil ang acceleration natin ay upward, ang reverse effective force direction, downward na. Kanina, upward. Ngayon, downward na siya. No? Baliktaran kasi yan. A at saka REF in direction nila. So, in that case, summation FB equals 0. So, we have N minus W minus REF is 0. So, PA, upward, no? Then, WMG, REF, MA. So, yan pa rin naman yung kanina. Yan, area. So, PA, MG plus A. So, tinranspose natin, no? So, kaya naging MG plus A. Then, M is rho V, G plus A. Ayan, where V equals to AH. So, therefore, P equals to rho H, G plus A. No? Cancel yung A. No? So, ating formula ngayon. At masisimplify ating formula natin ko-consider. So, plus ngayon siya. Kanina minus. Minus pag acceleration, plus pag deceleration. No? So, plus pag deceleration. Okay? So, imagine nyo, habang pailalim yan, biglang namreno. Pinreno niya, halimbawa, pinreno. Pag pinreno, babagal siya. So, anong tendency ng liquid? Mako-compress, di ba? Kasi, pinreno mo. Okay? So, kaya, ang mangyayari, tataas ang pressure. Kaya may plus. No? Tataas ang pressure dito. Kung ito yung concern natin, yung sa bottom. No? At kahit hindi bottom, no? Kahit sa part. So, tataas ang pressure. So, upward path acceleration naman. So, ganun pa rin. This time, upward naman. No? Yan. So, upward acceleration naman. So, wherein the direction of the path is the same as the direction of acceleration. So, sabihin niyan, habang paitaas siya, bumibilis siya. So, if that's the case, consider natin yung part na to. Weight, normal force. Okay, saan yung direction ng reverse effective force? Downward. Kasi yung acceleration ay upward. So, reverse effective force downward. So, summation of V0, ganun pa rin. N minus W minus REF. Okay. So, mag-arrive ka dito. No? Yun pa rin naman. So, mapupunta ka dyan sa part na yan hanggang sa mapunta ka sa answer na P equals to specific weight times H times 1 plus A over G. So, ibig sabihin niya, tumataas ang pressure habang paitaas na nag-accelerate. No? Imagine, pabilis ng pabilis habang paakyat. Therefore, ano mararamdaman ng liquid? Nararamdaman niyang nako-compress siya. Kung tao yan, nararamdaman yan para siyang kino-compress, pailalim, no? Okay? Ganun siya. So, upward path deceleration naman, no? Upward path deceleration, this time, pag deceleration, opposite sa direction ng ating path. So, ating direction ng acceleration. So, ibig sabihin, ito yung ating direction ng motion, upward, opposite sa acceleration. So, sabihin niya, deceleration. No? Okay, if that's the case, ganun pa rin. Meron kang weight, meron kang normal force, at the direction of the reverse effective force will now be upward. Okay, opposite sa direction ng A. And mag-arrive ka sa sagot na P equals to specific weight times height multiplied by 1 minus A over G. Ibig sabihin yan, nababawasan yung pressure. No? Nabawasan yung pressure. Okay? So, sabihin niya, bumibilis siya, hindi, paakyat siya na bumabagal yung kanyang bilis. No? So, ibig sabihin niyan, pinipreno. Paakyat siya, pinipreno. O pag pinreno mo, paakyat, tendency, yung tubig, yung liquid, tendency niyan, mapupunta sa taas, di ba? O kaya nababawasan yung pressure. That's the tendency na napupunta sa taas. Kaya nga ang reverse effective force pataas eh. Opposite sa acceleration. Okay? Kaya parang gumagaan, no? Parang gumagaan siya. Okay? So the pressure decreases, no? With respect to the normal pressure, no? Nag-decrease sa case na to, case 4. Alright, so we can proceed, no? With the problem, no? An open tank containing oil specific gravity 0.8 is accelerated vertically at 8 meter per second squared. Determine the pressure 3 meters below the surface. If the motion is upward with a positive acceleration, letter B upward with a negative acceleration, letter C downward with a positive acceleration, letter D downward with a negative acceleration. O, ito yung ating open tank, no? So, naka-open yan. Ang height ay 3 meters. So, oil specific gravity 0.8. Okay? So, ito yung direction ng acceleration, which has a magnitude of 8 meter per second squared. So, note, no? If the direction of the motion is the same as the direction of acceleration, then acceleration is said to be positive. Sabihin niya, yung positive acceleration na yan, sabihin niya, nag-i-increase ang speed habang nagmo-move siya, nag-i-increase ang speed. So therefore, pareho yung direction ng acceleration sa direction of the path or direction of the motion. So recall, formula, okay, dahil nag-i-increase ang speed, okay, habang pataas, so therefore, yung pressure, nadadagdagan yung pressure, no? Nag-i-intensify yung pressure. Okay? Direction of acceleration is upward. Kasi ang reverse effective force direction ay pailalim. Okay? Parang merong compressing force. No? Kaya plus yan, no? Okay? So, with that, so we have 0.8, 9.81. Ito yung para sa specific gravity. Ito yung para sa unit weight of water at 4 degrees Celsius. Okay? So, height is 3 meter. This is 8 meter per second squared. 9.81 meter per second squared. So, cancel. Okay. Ito, unit nito ay meter. Ito, unit nito ay kilonewton per cubic meter. So, kilopascal. Kilonewton per cubic meter. Multiply mo ng meter. Kilonewton per square meter. So, therefore, ang unit ay pascal. Kilopascal, I mean. So, 42.74 kilopascal. Next, letter B, upward with the negative acceleration. So, dahil negative acceleration, ibig sabihin nun, Habang pataas siya, bumabagal yung kanyang bilis. So therefore, opposite ang direction ng acceleration sa path. So acceleration is 8 meter per second squared. Note, if the motion and acceleration of a system are in opposite directions, the acceleration is said to be negative. No? So, ito yung ating formula. So, saan ang direction ng ating reverse effective force? Kung downward ang A, so upward siya. No? So, upward naman. Kaya, minus. No? So, direction of acceleration. So, direction of acceleration is the downward. No? So, P equals to 0.89.81 times 3. So, minus naman. So, sasagot niya ay, ang sagot ay 4.344 kilopascal. No? Okay, so, sabihin na bawasan yung pressure, no? So, next, C, downward with a positive acceleration. So, downward. So, acceleration, positive. Therefore, same ang direction of motion. So, direction of acceleration. So, if the direction of the motion is the same as the direction of acceleration, then acceleration is said to be positive. Okay? So, dahil downward siya, yung acceleration, minus. Okay? Pag upward yung acceleration, yung gitnang sign nito, plus. Pag downward siya, minus. No? So, P, 0.8, okay, yan pa rin, 4.344. Ang makukuha natin, kilopascal. Letter D, downward with the negative acceleration. So, downward with the negative. So, downward ang path, pero negative acceleration, therefore, opposite ang direction ng path sa acceleration. So, upward ang ating acceleration. So, therefore, ang makukuha natin sagot ay 42.74 kilopascal. Dahil ang reverse effective force direction ay downward dahil upward yung A. So, sabihin, lumalakas ang pressure. So, kaya plus, no? Okay, so that's all. So, I hope you get it.